Again, welcome to Waidsum Academy. Today we are looking at mathematics chapter 21, IGCSE mathematics chapter 21, and the topic is straight line graphs. Okay, I know we're familiar with this topic from grade 9 or lower grades, but we're going to look in depth of this chapter today. So without wasting time, let's start. Now we started with coordinates. Anytime we have a plane, a 2D plane, and we locate a point on a plane, then we are bound to be able to tell the coordinates. The coordinates has something to do with your x horizontal axis. The value, when you choose a point on a plane, you should be able to tell the horizontal value and the vertical value. So from that point, you trace down your horizontal value. Okay, in this regard, the horizontal value for this point A is 3, and the vertical value for this point A, if you trace it to this way, is 2. So our coordinate is 3, 2. Remember, you have to read the x value first before you read the y value. You have to read the x value first before you read the y value. So our point here is 3, 2. Now, what if we change we put another point somewhere here, but we call it point B for this particular plane. So if we call here point B, and then it means this one will be 1. You trace this B, point B to the horizontal axis, which gives you 1, and you trace it to the vertical axis, which is 3. So which means 1, 3, which means 1, 3. So if you're asked to give the coordinate of point B. If we decide to choose a point at this junction, and then we are asked to give the coordinate of this point, we read it to the x-axis, and then before we read it to the y-axis. So the x value is 5, and the y value for this one is also 5. So this one we say 5, 5 for the coordinate of C. Okay, so this is how we locate coordinate. Now let's look at a more broader 2D plane, where we have both the negative for y-axis and negative for x-axis. Okay, when we have a point here, point B, we call it point B. We read this one to the x-axis first. This point B, we read it to the x-axis, which means we trace it from here to here. We trace it from here to here first, which is 3, and then we write 3, we trace that same point to the y-axis, okay, to the corresponding y-axis, which is negative 3. So that's how we got 3 minus 3 for this coordinate. Now if we choose point 3 here, now what's the coordinate? This one we have to read it to the x-axis. Remember, you read to the x-axis first. It becomes negative 4, and then before you read to the y-axis, negative 3. Okay, so this one will be negative 4, negative 3, the coordinate of C. Okay, negative 4, negative 3. Now, what if you are in D here? What is the coordinate of point D? You read it to x-axis first, which is negative 4, before you read it to y-axis, which is positive 3. So this one will be negative 4, positive 3 for D. So this is how we read coordinate, okay? So okay, if you put a point here, you call it point A. I think A was exactly here. Okay, A was somewhere here. 3, 2. Okay, A was here. 3, 2. 3, 2. Okay, for the first A we did. Okay, so that's it. That's how to look at that. Now let's take a look at, pause the video, draw a scale for x and y axis from minus 8 to plus 8 for both x and y axis, and then plot all these points there. Okay, identify and locate these coordinate points in your graph. Okay, so do all these questions and pause the video and solve all these questions. Okay, now let's go to reading scales. Now point A, B, C, D are not all number points on the number line. Point A is 0.7. Okay, how? Let's zoom out first so you can see. It's 0.1, so you count 0.1, 0.2, 0.3, 0.4, 0.5, 0.6, and then 0.7 will be here. So that's which means A is on 0.7 on this scale. Okay, B is on 1.5 because this is halfway between 1 and 2. B is on 1.5 on this scale, and C is on 2.4 on this scale, and D is on 4.8 on this scale. Now on another scale, they give you another one. This time around, it's not just one box that is 1. 2 of it is 1, meaning 1 will be 0.5. So 2 of this small box is 1. So if E will be what? 0.4. This point E is 0.4. So you go to locate 0.4. Meaning in this case, not one box, tiny box that will be 0.1. Two tiny boxes will be 0.1. So you count to two boxes. Two, that's 0.1, 0.2, 0.3, there's 0.4. So 0.4 here, so you locate 0.4. Here will be 0.9. F will be 0.9. Okay, almost 1. Remaining two boxes to me, 1.0. Okay, this one will be 1.5, G will be 1.5, and this one will be 1.75. Okay, H will be 1.75. Okay, so we show, this is how we locate points on scale. Choose scale, draw a scale, and locate points on the scale. So here, you pause the video, answer this question. We have a scale here. You should be able to read the value of I, J, K, L, M on this scale. And also for this second question. And also for this one, the coordinate. Okay, A, which coordinate is this? 1, 1.5. That's for A. And so you solve all of this, point the graph as pause the graph, and solve all of it. Now let's go to the gradient of a straight line. We said the gradient of a line is given by y equal to ms plus c. This is the gradient of a straight line. This is the equation for the gradient of a straight line for simplicity. Okay. Now every line is a slope. A line that is vertical like this does not have a gradient. If it's vertical like this, gradient is 0. If it's also horizontal like this, the gradient is 0. We only calculate gradient for slopy line. Either positive slope, like this green line is a positive slope, and also this pink or red line is a positive slope. Now this one, this other green line, deeper green or blue, is a negative slope. So this one you're going to get a negative gradient. So you only calculate gradient for slopy lines, not vertical lines or horizontal lines, because those ones, their gradient is 0. Now we said the equation of a line is y equals to ms plus c, and m is the gradient, meaning every time you calculate the gradient and then you slot it to this formula, and c is the y-intercept, meaning where the line passes through the y-axis. For example, if this green line passes through, where does it pass on the y-axis? You locate it, that's the value of c, finish. You don't, if a line is given to you, you don't need to calculate, and you can get the equation. All you need to find out is the gradient for this line. Okay, you see, it passes through 1, so c is 1. In this case, c is 1. C is 1. So for this green line, c is equal to 1. Now let's calculate the gradient so that we can get the equation of the line. C is 1. M is what is remaining. Now how do we find M? M, for you to find M, or for us to find M, we have to choose 2 points, right? We have to choose 2 points on the line. Any 2 points that we feel that is convenient for us. We can choose here, or we choose even the beginning, or the topmost. You can choose this point and choose any other point you like. Maybe here. Okay. We can choose any. Okay, let's choose here. Okay, we're choosing these 2 points. Let's make it more conspicuous. This point on this line and the very first point. Now let's calculate the gradient. Remember, even if you choose here and here, you're going to get the same gradient. You're going to get the same gradient. Now let's see. You know, this forms a triangle. Once you choose 2 points, you can make a triangle out of it, and then you calculate the gradient. You can make a triangle like this, and then you can calculate the gradient. Okay. You did this in physics. You're doing it in maths. You done it in maths before in lower grade, so it's not a big deal. So it becomes something like a triangle. So remember, gradient is y2, m equals to y2 minus y1, y2 minus y1. You must remember the formula. Okay, minus y1 over x2 minus x1 over x2 minus x1. This is the formula we learned for gradient, right? So, and gradient is represented by m. It's represented by m. So we just write m equal to this. M equal to this formula. Now, what is the meaning of y2? Meaning the highest point, trace it to the y value, which is 4. In this regard, is equal to 4. So we write 4 minus, so we write this one 4. Y2 is 4, meaning the highest point. You know, we chose 2 points. The upmost one, trace it to the vertical axis. You write it down. It's very simple. This is not a big deal. Then the lowest one, the lower point, trace it to also the y-axis, which is 0. So you say 4 minus 0, right? We say 4 minus 0. 4 minus 0. Over. Now let's trace the same point, trace it to the x-axis. So the highest one will be x2 over this one is 6. So I write 6 here. I write 6 here. The lowest one was the x-axis. The lowest one is on -2. The lowest one is on -2 for x-axis. It's already directly on the x-axis. So you say minus, don't just write -2. There are two minus in the formula, this minus in the formula, and this one is -2. So there are two minus that we're going to write. We're going to write two negative. So -2. If you forget to write the second negative, you're going to get it wrong. You're going to get your graded wrong, okay, based on what you have chosen. So this one will be equal to, 4/8. Because 6 minus -2 will be 6 plus 2. Minus is plus. So this becomes 4/8, meaning our gradient is 1/2 or 0.5. Our gradient, since it's 4/8, our gradient is 1/2. Our m is equal to 1/2. So we go back to create the equation of a straight line. So once you know the gradient and you know the y-intercept, where the straight line passes through the y-axis, which is 1, then finish, you write your equation. Now, remember the equation is y equal to ms plus c. Now you come and slot in the value of m and c only. You get your equation of a line, of a straight line. So we just come, we put the values here. What is our m? Half. So I write half x. I write the value of the gradient I just calculated, which is 1/2. I write 1/2x plus, what is the value of our c? Our c is 1. Remember, this line passes through 1. So I say plus 1. So this is the equation of the straight line, that straight line, the straight line that we highlighted. This is the equation of the line. This is the equation of this straight line. Is that okay? Now, what about this one? If you want the equation of this green line, we calculate the gradient. We can choose this point. We can choose this point and this point. We can choose these 2 points, okay, to calculate the gradient. So I will no need to write y2 minus y1. You already know the formula. I will just write the values out. So I'll say gradient for this one is equal to, trace this point to this way, 3. So I'll say this is equal to 3 minus, that's the y2. This is our y2. So the highest point we chose is 3, right? So we say 3 minus, what's our lowest point? What's the y value of our lowest point? -3, right? This is the lowest point. Trace it to the y-axis, you get -3. So remember, you not just write 3. There are two minus now. One is in the formula. This one is the formula for the minus. And this one is -3 on the second y value. All over, trace them to the x-axis. This one is 2. The highest one traces to the x-axis, which is x2. You get 2. And the lowest one, trace it here, you get -1. So you're going to say 2 minus 1. Okay, so this one will give us 6. 3 minus 3, you get 6 over 2 minus 1, you get 3. So 6 divided by 3, you get 2. So in this case, our gradient for this line is 2. You can see it's steep. It's steeper than this one. This one, the gradient was half because it's not very steep. But this one is steeper. You know the meaning of steep one. So now we write the equation. So m is 2, and then c is what? C is equal to -1. C is equal to -1. If a line is drawn for you, you don't need to calculate c. It's only when they did draw the line for you, we calculate c. I'm going to show you later how you calculate c. So we're going to substitute this into the equation of a line. Remember the equation of a straight line? Y is equals to mx plus c, right? So the m is 2. We already calculated the gradient to be 2. So you write 2x. Instead of say ms, you say 2x. Because you got the gradient to be 2. So you say 2x. And remember c is -1. Instead of say plus c, since c is -1, you say -1. You say -1. This is the equation of the red line. This is the equation of the red line. So this is the equation of this straight red line. Okay? This is the equation of this straight red line, this one. Okay? Now, okay, maybe I itemize it, I show it, so that we highlight it, so you can see. Let's use a different color to highlight it. Let's use this color to highlight it. So we just calculated the equation of this straight line. The equation of this straight line. So once you know how to do all this, then your job is easy. Now let's go to this one. This one is a negative gradient. You're going to get a negative m. M you're going to get is going to be negative. Why? Now because it's sloping this way, the opposite way. Now we can choose this highest point and lowest point to calculate this gradient. You can choose this first point, the tallest point. You can select, you can even use here and here. You know this here we put before? You can use it so you can draw a track. Okay, let's use the, since we already have a point on that coincidentally fell on the line. So let's use this 2 point. But no matter where you choose as your point, you get it the same gradient. You get it the same gradient. Whether we use the tallest point and the lowest point, we're going to get the same answer. Okay, now, if we are using here, what is our m? So y2, our y2, trace this point, highest point to this place, you get 4. Our y2 is 4, so write 4 here. Minus, what's the lowest value in the y-axis? I think it's 0, right? Because the point is here. To trace it to the y-axis is 0. So we get 4 minus 0 over. Now trace each one to the x-axis. Trace this one to the x-axis. You get negative 6, right? So you get negative 6. You get negative 6. And trace this one to the x-axis is on negative 2. So you get negative 2. This one is directly on negative 2. So you can see this one is 4 over negative 8. This one is 4 over negative. Of course, you get negative 1 over 2. See, this one is 4 over negative 8. So our gradient for this line will be, you always have to simplify the value. Leaving it like 4 over negative 8 doesn't make you look like a good mathematician. So you have to simplify the value to the lowest, simplest form, which is 1. 4 divided by 4, you get 1. Negative 8 divided by 4, you get negative 2. So you get 1 over negative 2. Or you can simply say negative 1 all over 2. Okay, so that's our m. What of c? Where does this line touch the y-axis? It touches it at negative 2. So our c value is negative 2. Our c value is negative 2. So once you have your m and c finished, you already got your equation of a line. You just to slot them into the equation formula. Okay, so now we get x. Remember to put x this time around because you are substituting for m only. Negative 1 over 2x minus 2. Instead of c, you put minus c. C is negative 2. Finish. This becomes your equation. This way. Okay, let's take another color to highlight that line. Okay, something like a pencil. Let's use something like a pencil to highlight this line and its corresponding gradient. Okay, you see it's a negative gradient. This line, we got a negative gradient. That's what we got for this. That's what we got. That's the equation. This is the equation of this one. So this is the equation for this one. Okay, so that's it. I hope you understand. Okay, so this is how we calculate the equation of a line. We give you simple example. This one I'm just going to follow what we already have here. You have point B, point A on top. So we always say the one on top, the y value of it minus the y value of the one at the bottom. So this is going to be 3 minus minus 3. 3 minus minus 3. Why minus minus? Because this one is negative 3. 3 minus minus 3 when you are calculating the gradient of this. Remember, gradient is the vertical distance between 2 points over horizontal distance between 2 points. And I said always make a small use broken lines to make a triangle. Use broken lines to make a triangle. Once you do that, then it's easy for you to calculate. Now let's take a look at this. Let's take a look at this. This is 3. Y2 is 3 and YY is negative 3. So 3 minus minus 3, which is equal to 6. And then trace this one down, 2 for the y-axis. 2 minus, trace this one to the y-axis, minus 1. 2 minus minus 1, which is 3. So 6 divided by, you get 2. That's how we get this gradient to be 2. Okay? We have calculated this one already. We got 2. Let's go back to the color we used to highlight it. The color looks like fainty. Which color was this one again? I think it was this one, right? Okay, so this was it. This was it. And you must get the same answer, like I said. No matter what you chose, you must get the same answer. And this is the equation of the line. This is the equation for that line. Okay, so here they are just repeating what we have done. And this is the formula for calculating gradient of a line. Y2 minus y1 over x2 minus x1. Okay, well, that's it. And you need 2 points to calculate a gradient. The negative one, I've calculated this already. We got this gradient to be minus 1 all over 2, I guess. So they use the tallest and the lowest probably here, this point, and this lowest point, and this lowest point. So like I said, it doesn't matter where you use. Here will be 4 for y2, and here will be minus 4 for y1, which will 4 minus 4, which is 8. Okay, divide by, then trace this one to x-axis, negative 6, trace this one to x-axis, 10. Negative 6 minus 10, that's minus 16. So 8 over negative 16, you get minus 1 all over 2. Okay, it doesn't matter where you choose, how you choose, which point you choose. In the end, you get the same gradient, minus 1 all over 2. Okay, so we've studied this, we've done this already. Let's move on quickly to explaining. So if a line is like this, if it's sloping like this, like this, you're going to get a positive gradient. If a line is sloping like this, we're going to get a positive gradient. If a line is sloping like this, we're going to get a negative gradient. We're going to get a negative gradient. Is that okay? Now let's move on. So these two lines, for example, these two lines, they will give you positive gradient because they both sloping like this to the right side. Okay, these two lines will give you a positive gradient, but this one's value will be bigger because it's steeper. A steeper line gives a bigger gradient. Okay, a steeper line gives a bigger gradient. This one you can get 2, this one you can get half or 1. Okay, depends on the values. Okay, so we've done all of this. I think we've done all of this. We've calculated the gradient, and I've done the negative one like this also. You can calculate, okay, this one is a negative gradient. This one will give you a negative gradient. This one will give you a negative gradient. Is that okay? Similarly, this one will give you a less steep as this one. So, is that okay? Now, let's move on. For lines like this, horizontal line like this, there's no gradient. Gradient is equal to 0. Equal to 0. There's no gradient or out of bound or infinity. Similarly, a vertical line like this, I mentioned this at the beginning, right? Vertical line like this, there's no gradient. Gradient also equal to 0. Equal to 0. We only can calculate gradient for slopes. We only can calculate gradient for slopes. Okay, for this line B, they ask you what's the gradient of this line? 0. Is 0. What's the gradient of this one? F. Line F is 0. What's the gradient of this one? Okay, this one you can calculate, you can tell. This one is a positive gradient. You go for line E, you go to get a positive gradient, but it's not so steep. The value is lesser, maybe half or 1. While line A is a steeper line, you're going to get a positive gradient and a greater positive gradient. This one is a negative. Line C is a negative gradient. It's steep, so you're going to get a bigger value. You know, bigger value for negative means smaller actually. Okay. Then this one is also a negative gradient. Okay. So you should be able to understand. Now they are treating the equation of a straight line. I've already treated the equation of a straight line. Okay. So when you are given a line on a graph, first of all you calculate their gradient, and then you find where they touch the y-axis. That will be their value of c. You slot it to the equation of a straight line. You slot those two values of gradient and c, y-intercept, into the equation of a straight line. This is why you don't have a gradient for this type of line. Why? Because all the y value is 4. 4 minus 4. If you choose any 2 points, 4 minus 4 is 0. So you're not going to get a gradient. Okay, but if a line is like this, you're going to get a gradient. Why? Because there's a progression. There's a progression in the change in y and change in x. There's a gradual change in y value and change in x value. So you can say this one. You can do that. Okay. 8 minus 2, that's 6 over 4 minus 1, which is 3. 6 over 3, you get 2 as the gradient of this line. Okay, if you choose. So the gradient of this line is 2. You can even use your table to calculate gradient. If I choose this point, y1, y2, the highest one is y2, the lowest one is y1. This will be x2, and this will be x1. So it will be, gradient is change in y, meaning 8 minus 2, which is 6, 8 minus 2, which is 6, over 4 minus 1, which is 3. So 6 divided by 3, you get 2. You get a gradient of 2. Okay? You can use your table or you use your graph to calculate the gradient. It's as easy as that. So since this one passed through the origin, you know, origin meaning the c is 0. C is 0. So if you slot this one into the equation of a line, it will be 2x, y equal to 2x plus 0, which is simply y equal to 2x. This is y equal to 2x. The gradient is 2, remember that. Gradient is 2. So remember the equation of a straight line, y equal to mx plus c. This is the equation of a straight line, y equal to mx plus c. So if we substitute m and c to this equation, remember c is 0. Why is it 0? Any line that passes through the origin, 0 is called the origin point of origin. I substitute this value of m and c. Remember we got m to be 2. So I will have y equal to 2x, y equal to 2x. If I want to write the equation now, y equal to 2x plus 0. So plus 0, no need to say plus 0. So the equation becomes y equal to 2x only. Because plus 0, 0 is nothing. So no need to say plus 0. So the equation for anyone that passed through origin, you just have y equal to 2s, y equal to 3s, y equal to 5s if it's a positive slope. If it's a negative slope, you may have y equals to negative 3x if it's passed through the origin. Is that okay? So at this point, pause the video. Okay, for this one, like we said, there's no gradient. Gradient is 0, and then the equation of the line. How will you not write the equation of a line? This one will be y equal to 7. 0x. You know 0x means 0. So 0x, because the gradient will be 0, y equal to 0x plus 7. Because the line touched y-intercept where it touched the y-axis is 7. Okay, this line touched 7. So 0 times x is 0. So no need to write 0. We just say y equal to 7. So the equation of this type of line is y equal to 7. Okay? You don't even need to solve. For if you have this type of horizontal line, the equation of the line will be y equal to 7. If you have this type of line, the equation for this is y equal to 2. You don't need to solve. You just say the equation of this line is y equal to 2 because it does not have a gradient. Since gradient is 0, then you don't need to write anything with x. So this one you just say y equal to 2. That's the equation of this line. 0. This one you just say x equal to, and gradient is 0. So this one, the equation is just x equal to 7. This is the equation for this type, x equal to 7. Because why? Because the line touched the x-axis at 7. The line touched the x-axis at 7. So for vertical line like this, you just say x equal to 7. And for this one, you just say the equation of this line is x equal to 3. X equal to 3. This is the equation for this one. Okay? This type of vertical and straight line, you don't get the sloping function. You don't get its function. Okay, but this one, yes. But this one passes through the origin. But to calculate this, you have to get the gradient. You have to calculate the gradient. So 8 minus 0, if I choose the beginning and at point 8 for this y-axis. So 8 minus 0, I get 8. So if I want gradient, I'll say 8 divided by, I'm choosing here. So I trace here 8. The bottom one, I'm choosing the bottom one, 0. So 8 minus 0, I get 8 over. Trace this one down, 8 also, minus 0, 8. So the gradient of this line is 8 divided by 8, which is 1. So my m, the gradient for this one is m equal to 1. Now write the equation of a straight line for this one, m equal to 1. You get the equation. It's similar to what we have been doing, okay? Don't panic. Or if they give you this way, they want you to put it this way. They can ask you to put it in this format. He said the equation of a straight line is given as y equals to this. So what you do, if you are given something like this, you are given the normal equation of a straight line, but they want you to put in this form. It's very simple. First, move this one to go and meet y. We go move it to the left, become minus half x plus y plus y. Move 3 to this way. Okay, move 3 to this way. It becomes minus 3 equal to 0. Minus 3 equal to 0. You can leave it like this, or you can divide by minus 1. You can leave it like this. If you don't want the first number to start with negative, you divide here by negative 1, you get positive 1 all over 2x. You don't want the very first one. But it does y, it is no longer going to be plus y. Okay? And then you also divide that here by minus 1. It's now going to be plus 3. Then equal to 0. This is the equation. This is the form they want you to put it. This is the form they want you to put it. Is that okay? And you can still simplify further by multiply through by 2. Why? Because we want to remove fraction. If I multiply here by 2, these 2, we cancel these 2. I will also multiply here by 2. I will have minus 2y. I multiply there by 2, it will be plus 6. So the new equation will be x. The new equation will be x. Why is it x? Because this 2 here divide this 2 here. So only x remain here. So if you multiply minus y by 2, you get minus 2y by 2. Because it's 1 all over 2. Because it's 1 all over 2. That's why I'm multiplying by 2. If it's 1 all over 3, I would have multiplied through by 3. Okay? So it's not like it must be multiplied by 2. No, it depends on what the fraction is. If the denominator is 5, I'm going to multiply through by 5. If the denominator of the fraction is 5, I'm going to multiply through by 5. So here you multiply by 2, you get minus 2y. This plus 3, you multiply by 2, you get plus 6. You get plus 6. You get plus 6 equal to 0. 0 multiplied by 2, you still get 0. So you just write 0 on the right. So this is the format they want you to put it, ax. Remember, a here is 1. The coefficient of x is 1. And then b here is negative 2. And c, the constant value is 6 plus 6. This is the format they want you to put it when they give you. So this one example should be enough. You should be able to solve, put any, so that we can move on. You should be able to put any equation of this format. So you should be able to put it in this format. First, move everything to the left. You equate to 0. And then you multiply through by the denominator of what you have. And if there's any fractional one, if there's no fraction, then you just leave it like that. If there's fraction, then you do that. Now in this case, for example, they give you this. You move this one to the left, but multiply by minus 1 so that this one, since it's starting with x, it will be positive. And this y will be negative. Okay? Or another way is by saying move y to this side. Okay? You just move y to this side, then you equate to 0. That's another way of saying if you don't want to say. So it means if you're moving y to the right, it means 2 over 5x, then minus y, then minus 1 over 3 equal to 0. Equal to 0. Okay? Because we want the first one we are starting with to be positive. It doesn't mean if it's negative, it means anything. It doesn't mean anything. It's just making it nicer, looks nicer a little bit. Okay? So it's like just instead of saying multiply by minus 1, just move y to this side. And then you equate everything to 0. Is that okay? So that's what we have here. We start from here. 2 over 5x. Then we move this y to the right. It becomes minus y. Then this one was already minus 1 over 3. Minus 1 over 3 equal to 0. So now you have this. You go to multiply through by the LCM of the denominator. Now you have two fractions, you know, right? And the LCM is 15. So we're going to multiply through by 15. Okay? We're going to multiply through by 15. So meaning I will multiply here by 15. Okay? Or you find the LCM. Okay? So meaning I'm going to multiply here by 15 because we must find the LCM of the denominator. The denominator, usually the LCM is the product of the two numbers in the denominator. So you're going to multiply here by 15 because the 15 is the LCM, lowest common multiple. You're going to multiply this one by 15. You're going to multiply this one by 50. If you do that, this one will be 5 here 1, 5 here 3. 3 times 2, you get 6x. So we're going to have 6x. We're going to have 6x. Then multiply here by 15, you're going to get minus 15y. Minus 15. Minus 50y. Then multiply here by 15, you're going to get minus 5 equal to 0. Finish. You put it in that format. You put it in the format of ax plus by plus c equal to 0. This is the format. You've simply reduced this equation of a straight line that is like this in the normal format. You've put it in this format. Ax plus by plus c equal to 0. That's it. Okay, so here, pause all this, solve all this question. Put them in this format, ax plus by plus c equal to 0. Put all this one in that format. Easy, pause, solve. You don't solve, you're doing good. Okay, now let's move on. Pause and solve. Now let's move on. Parallel lines and their equation. If two lines are parallel, for example, if you have two parallel lines, the gradient of one is equal to the gradient of the other one. The gradient will be same. Parallel lines, if this is line 1, the gradient of line 1 will be equal to the gradient of line 2. But if lines are perpendicular, the gradient is not same. Okay, we're going to talk about that later. But let's talk about parallel line. So which means the only thing you care about them, if you have a, let's say this is your y-axis. Okay, the only difference in the equation, what will differ the equation, is the value where they touch the y-axis, the c, which is the y-intercept. Let's say this one is touching at 5. Let's say this line 1 is touching the y-axis at 5, and let's say this one is touching at 3. This one is touching at 3, right? Now they say write the equation. You know, let's say they have the same gradient and the gradient is 2. So to write the, let's say m is 2, because the gradient for one is the same as the gradient of the other. The m1 is equal to m2 if two lines are parallel. Please keep it in your mind. These questions are always in IGCSE paper. You don't know, then you go to fail. You don't know, you go to fail. Okay? So if two lines are parallel, this is the meaning of parallel line. You know, right? You know parallel lines. Two straight lines that will never meet are called parallel lines. Now the gradient of one is the same as the gradient of the other if two lines are parallel. Okay, so to write the equation of the line, let's assume the gradient is 2 for this line. Let's assume the gradient is 2. Now write the equation of the line. This will be for line 1. For line 1, you say y1 is equals to, what's the gradient? 2x. You write 2x. You put it, remember you use this equation of a line. You use this equation, y equal to ms plus c. Always remember, this is what we use for equation of a straight line. Y equal to mx plus c. This is what you use to fix equation or to write equation of a straight line. Okay? Anytime you are asked to write equation of a straight line, you write this equation, then you look for m, you look for c. Remember, they've told us the m is 2, the gradient same 2. So I write y equal to 2x instead of write 2x, the 2 here, the gradient. 2x plus c. For line 1, it touches the y-axis at 5. So I'll say plus 5. So this is the equation of line 1. For line 2, what differs? The gradient is same. The gradient is same. So this one, y2, if you like to call it y2 or you just call it y, is equal to, the gradient is same, so I'm going to write 2x. I'm also still going to write 2x. But what differs is where it touches the y-axis. This one, line 2, is touching at negative, not negative, at 3. So I'll say plus 3. So wherever it touches, this is the only difference. If two lines are parallel, they have the same gradient, but only the value that is different is where they touch the y-axis. That's what makes the equation differ. Okay? If not, the equation would be absolutely the same. Okay, so I just hope you understand. Where two lines are parallel, they will have the same gradient, and what differs is where they touch the y-axis. Is that okay? Okay, so I'm going to move faster. I may not follow them. A straight line has the equation y equals to this. Another straight line has the equation y equals to this. Explain, give it easy, whether the two lines are parallel. No, they are not parallel. Why? Why are they not parallel? Because the first line has a positive gradient, 2. The second line has negative 2. This is negative slope. Why this one is a positive slope? They are not parallel. Can you see a line like this and a line like this be parallel? No. So these ones are not parallel. Okay, so then even if they give you the one that looks like this one, you have to rearrange. You rearrange this one, and you rearrange this one, and you see whether they have the same gradient. You rearrange in the form of equation of y equal to ms plus c, meaning by moving this one to this way, and also rearrange this one by cross multiplying. You rearrange, and you tell whether they have the same gradient. If you rearrange, let's see, this one has this equation, and this other one has this equation. Yes, this one, they are parallel lines, because the gradient is 2, and this one, the gradient is 2. Once you rearrange, you'll be able to tell. Okay, even if it's disorganized, you rearrange and you should be able to tell. Is that okay? Now this is a further question on how to deal with parallel lines. Now let's go to this question now. The question goes beyond just what you know. A straight line A has equation of y equal to negative 3x plus 6. Okay, this is the equation of a straight line A. A second line B is parallel to line A and passes through the point coordinate. They're giving us coordinates. He said the two lines are parallel, so they have the same gradient. The gradient of the second one is also -3. You don't have to calculate the gradient of the second line. So since you know the gradient of the first one, they say they are parallel lines, so the gradient of the second one will also be -3. The only thing we need to calculate is the C, the y-intercept. Remember, there's no graph, but they give you a coordinate point that will enable you to calculate the y-intercept. Okay? Now calculate the equation of line B. This is exactly the pattern you will find the question in Cambridge IGCSE paper. This is one of the ways you easily find the question in Cambridge IGCSE paper. Now, what do? We go to find C is the y value. We're going to substitute them into the equation of a straight line to find C. Once we find C, then we can write the equation for line B. Okay? The coordinate of B is this second line. Now, let's find C. Using this equation, y equal to mx plus C. Y equal to mx. Y equal to mx plus C. So we're going to substitute. In this case, once they give you a coordinate point, remember we are looking for C. We don't know C. We don't know C, okay? But we know M. We know M. We know Y. You know what's the value of Y? 10. So that we can find C. We want to make C the subject. We want to find C. So our Y is 10. So I put 10 here. Remember, we are looking for C. So this one, I say pay attention. This is different from the ones we'll be doing. Okay? And this is the type that they will bring in Cambridge IGCSE paper. So 10 equals to, what's the gradient? How do you know the gradient? Because the first line, and they are parallel. The first line, the gradient is -3. So the second line, line B, the gradient will also be -3. So I'm going to put -3 here. The gradient of line B will also be -3. So I'm going to put -3 here. And what's the value of x? X is what? -4. Look at x. It's given as this in this coordinate point. So you take that value of 4, put it here, -4, put it here. You multiply by -3, and then you say plus C. Then now we evaluate and find C. You say plus C. Now let's evaluate and find C. So if you multiply this, you're going to get 12. It's going to be positive because -3 times -4, you're going to get positive 12. So we have positive 12 here, right? Equals to 10 here. 10 is here, which is the value of Y. Then this way, you say plus C. Now we are making C the subject, meaning move the 12 to this other side, move 12 to this side. So it will be 10 minus 12. If 12 come to join this way, it becomes 10 minus 12. 10 minus 12 equal to C. Equal to C. Equal to C. 10 minus 12 is -2. Not 2, okay? Please don't make those small mistakes. 10 minus 12 is -2. So C is what? Our C value is equal to, the moment you find C, remember we know the gradient because they are parallel line. If two lines are parallel, the gradients are same. So now we write the equation for the second line. We're going to write the equation for the second line. So you say Y equal to, we always write equal to mx. So the m is what? -3. The gradient is -3 for the first line. So it will also be -3 for the second line because they are parallel. Remember we say parallel lines, the gradient is same. So I write -3x. After you find, we only use this value of x and y to find C. After you find C, you don't write the values again. You just come and write the normal equation you know how to write before. Now plus C. In this case, C is -2, so we're going to say -2. Now this is the equation of line B. This is the equation of the line B. Y equal to -3x plus -2. This is the equation of line B. This is what you see. That's what they gave you here. So you must learn to find C. After you find C, you substitute the value of C here. Remember, the gradient will be same for line A. Why? Because they are parallel lines. Remember, like we said, when two lines are parallel, the gradient of one is equal to the gradient of the other. The gradient of one is equal to the gradient of the other one. Please keep that in mind. Okay? Now here is exercise for you to pause and solve. The more you do, the better you become. You want to study engineering, you want to study medicine, you want to study applied sciences, you want to study pharmacy, please solve as much as possible mathematics. Any form of engineering, chemical engineering, robotic engineering, aerospace engineering, mechanical engineering, electronics engineering, electrical electronics engineering, any forms of engineering, communication engineering, telecommunication engineering, biomedical engineering. Any form of engineering, you have to be very good in mathematics. Okay, pause this video and solve as many as you can. Now, drawing the straight line graph. Okay, drawing the straight line graph. The straight line graph, easy, right, to draw. Plot the value. Okay, we already did plot here of a graph in chapter 18. So you have this, you can choose values of x, or we can sketch. You can just use when x is 0, you get y is 3. And when x is 4, you can just choose like two values. When x is 4, y will be 7. So we can just have x value, y value. You can choose 2 or 3, and then we sketch the line. Okay? When x is 0, what will be the value of y? You substitute 0 here. So y will be 3. So y will be 3. And now we can choose 4. When x is 4, or you can choose any number. You can say 3. If you choose 3, this one will be 6. When x is 4, y is 7. Okay? We can use only these two. So meaning when x is 0, y is 3. Trace it here. You put the point here. And when x is 4, y is 7. Okay? When x is 5, or when x is 6, so if you have these 3 points, you can sketch your graph. And x is 6, this one to this point. Okay, so this becomes your equation of a line. It says sketch it, finish. You just sketch. X is 0, trace it to the value of y, which is 3. X is 4, trace it to the value of y, which is 7. X is 6, trace the value of y, which is 9. Then you join. You take a ruler, you join. Finish. You already plot your graph. Is that okay? You don't have to. So just always start from 0. When they give you a line to plot, they plot the line y equals to minus 2 as well. Just choose like 2 points or 3 points. It's different from the chapter 18 a little bit. 18 you have to plot a very wide range of graph. But this one you just like your sketching. Okay, you just say y equals to this. When x is -2, y will be 0. This one we are starting from -2, 0. So we can make a table also. X is -2. This is y. Okay, we have -2. We have 0. Okay, we can have 2. Okay, let's say I have this one. Then y will be, if this one is -2, -2 times -2, you get 4, right? Y will be 8. If x is 0, 0 times this, you get 0, then y will be 4. If x is 2, put 2 here. 2 times -2, you get -4. -4 plus 4, you get, and y is 8. -2, trace it to y is 8. Trace it to your y is 8, so you get to this point. Then the next one, x is 0, meaning you should be on the 0 on the x at this point. X is 0, trace it to y is 4. Trace it to y is 4. You put a point here. Put a point here. Okay? Put a point here. Put a point here. The next one, x is 2, y is 0. X is 2, y is 0. Y is 0 is here. You know, this is 0 value for y. So meaning you put a point here. And then you use a ruler, you join all these 3 points together. You get your, that means you sketch your graph. You all know how to plot graphs, so let's not waste time here. So here, pause the video and solve all of this one, okay? Now let's see, how do we use graph to solve simultaneous equation? You know, you study simultaneous equation in chapter 11. Okay, chapter 11, between 11 and chapter 13, you've done a simultaneous equation. But graph one is the easiest one. You know, simultaneous equation, you have to solve. No, this one you don't have, you have 2 equations, right? You see, like s plus y equal to 4. One of them will be a negative gradient. So what you just need to do is to sketch the 2 lines, like the sketching we just did just now. When we sketch s plus y equal to 4, this is the line. And then the second line, the positive one, you know why this one will be the negative gradient? Because if you make it in the form of equation of a straight line, it will be a negative gradient. You choose 3 plus 4. Okay, you rearrange before you make a table and you sketch. Then the second one, minus y equal to minus x, or you act like you move y to this way and move 2 to this side. So it's like you move y to the other x. You can see this is a positive x. The gradient is plus 1. Okay? Minus 2. Okay, this one is minus 2. Okay, so this one will be the positive gradient. Now you can make a table for these two, and then you sketch them on your graph paper. Now, how do you use them to solve simultaneous equations is very easy. Where they meet. The place they meet is the coordinate of the solution. So if they meet, where you sketch this graph and you sketch this graph, they meet at this point. That's the solution. Read this one here, 3, x equal to 3 and y equal to 1. That's the answer. Finish. S equal to 3, y equal to 1. You know the simultaneous equation you used to solve and you get s equal to this, y equal to this after you finish. Once you use a graph, this is what you do. So let's say for the first table, for the first equation, let's say we have minus 2. We're only going to choose like two values, 0 and 2. Minus 2, 0, and 2. What will be the value of y? Minus 2, that's plus 2. Here will be 6. Because there's negative here, negative 2, negative 2, that's plus 2. Plus 4, you get 6. So here will be 6. The y here will be 6. Then if you put 0 here, 0 plus 4 here will be 4. And if you put 2 here, negative 2 plus 4 here will be 2. So you can sketch this one. You can sketch this one. So we say negative 2. Okay, they did start from the negative side. Negative 2 will take you to 6. If you negative 2 would have been if you extended this graph. Okay, since they started from positive, let's choose 4. Let's start from 0. Okay. Then 4, if you put 4 here, it becomes negative 4 plus 4, you get 0. You get 0. Okay, now let's start from this, the 0. So when x is 0, y is 4. When x is 0, you see the x-axis. When it's 0 traces to y is 4. You get your first point here. When x is 2, y is 2. When x is 2, trace it to y is 2. See, this is where y is 2. See, y is 2 here, x is 2. And then when x is 4, y is 0. X is 4, y is 0. Y is 0 at this point. This point. If you trace it here, y is 0 on the y-axis. So you use a ruler to join. This is your first graph. Then you make table for this second equation. You also make table for this second equation. You also make table for this second equation. And then you sketch that second equation. And then where they meet, where they intersect, where the two straight lines intersect, that's the solution of your simultaneous equation. Okay, here let's also use 0, 2, and 4. So when x is 0, 0 minus 2, you get negative 2 here. Okay, this one I think we start from 2, you have 0. When x is 4, 4 minus 2, you have 2. Okay, let me choose one more here. When x is 6, when x is 6, 6 minus 2, because when x is 0, you have negative 2 for y. So this one, they did go down for this. It's up to you. You can go down, okay, in your negative side. Okay, but here, when x is 2, y is what? 0. X is 2, y is 0 is this point. This point. x2, y is 0 is this place. Okay? Then when x is 4, y is what? Y is 2. You trace this one here. Y is 2. When x is 6, which they didn't include, okay? Okay, let's do 5. When x is 5. When x is 5, 5 minus 2, you get 3. This one will be 3. Y will be 3. So trace 5 to 3. Oh, 5 is here. 5 is here. 5 to 3 is here. This point, somewhere here. So you can join the line. 2 points is enough anyway. You can join the line there. Where they meet, where the two lines meet, forms the solution of the simultaneous equation. If you trace this one down, you say x equal to 3. You say x equal to 3. Method, elimination method, equity expression method, but we've never used the graphical method to solve simultaneous equation for you. Okay, so with this opportunity, this video has presented the opportunity to use the this to solve simultaneous graph to solve simultaneous equation. Okay, so I think we'll move on, pause the video and solve any of these equations. Calculating the length of a line segment. Okay, there's a formula for length of a line segment. Now, let's say we have line point, we choose 2 points, point A and point B. Okay, the length has a formula. We call here A, and please note the coordinate value of each point, the coordinate value, the x and the y value. Okay, so if you are distance, this distance, okay, it's different from gradient. We are not talking about gradient, we're talking about the distance, okay, of line AB. AB is equals to here, the square root of x2 minus x1, x2 minus x1 square, x2 minus x1 square. So we go to bracket and square them. Plus, we're going to square this one. Plus y2 minus y1 square. Please take note, this is the formula for calculating the distance between 2 points. This is the formula for calculating. If you don't know, please go and practice. Watch this video many times and pause it and solve the question. This is the formula for calculating distance between 2 points. Actually, what it means is that, this is, if you use broken line, you can see you form a right angle triangle. You form what? A right angle triangle. So Pythagoras theory says here square plus here square is equal to here square. You remember that, right? So here square is the x2 minus x1. This is the change in the horizontal axis. So you say it simply means x2 minus x1 squared. Okay? And y vertical square is this one, y2 minus y1 squared, equal to here square. So if you take the square root of both sides, this one was square before. If you take square root and you also take square root of this one we took, this one was ab square equal to here square plus here square, meaning the distance from here to here in Pythagoras theory, ab square is equal to this one square plus this one square. So if I take the square root of ab, square root will cancel square. That's why it became only ab, no more ab square. And then you take the square root of the other side. Is that okay? So please take note, this is the formula. Now how do we find x to 5? What's x1? 1. So we're going to say 5 minus 1 square. So we're going to say 5 minus 1 square. 5 minus 1. 5 minus 1 square. Plus, let's do the y2 minus y1 square. Where's y2 minus? What's our y2? 6. This is our y2. Here's our y1? 3. So we're going to say 6 minus 3 squared. So here we're going to say 6 minus 3 squared. 6 minus 3 squared. They're all square roots. That would be equal to our AB, distance AB. So when distance between 2 points, please put the formula in your mind. It's very easy. S2 minus S1 square plus Y2 minus Y1 square, all square root. So this one, you find the difference, which is 4. 4 square will give us 16. Remember that. So here we have 4 square plus this one we have 6 minus 3. We get 3. 3 square will give us 9, right? Then you put your square root. So 4 square is 16. So 60 plus 9. 3 squared is 9. 60 plus 9, that will give us 25, right? Or square root. So if you find the square root of 25, this will be equal to root 25. So if you find the square, it's just like the modulus of a vector. Okay, when you get to vector, okay, or the magnitude of a vector. Okay, so if you find the square root of this, you get 5. So our distance AB is 5 units. This distance is 5 units. Distance AB is 5 units. Okay, so that's it. This distance is 5 units. That's it. It's as simple as that. So I hope you understand, but please pause the video. Another way, just if you don't want to follow the formula, just find the horizontal difference. What's the horizontal difference? Just say 5 minus 1, 4. You put the 4 here. Put the 4 here. And then 6 minus 3. 6 minus 3 on the y-axis. You know, this is the y, change in y. Find the change in y, which is 6 minus 3. You write 3 here. So using Pythagoras theorem, you get this, okay? So here's the formula. I've already given you the formula. Here's the formula, okay, to find the distance between 2 points. Distance D, or AB, if you like call it AB, or distance D,